sitting in the morning sun.
Today we will be solving problem number 6 from the lab numerically. Here, as you can see, we have our function, and it says that the limit is approaching 3. So, now, because in this problem it says that the limit is approaching 3, we will be making a table, and then in the middle putting number 3 right here. And then, because we have to look to see if there is a limit, we have to put 3 values to the right and 3 values to the left. The 3 values to the right will be a bit bigger than the 3, and the ones to the left will be a bit smaller than 3. So here, 2.001, and then 3.01, and 3.1. And then on the other side, I will be putting the ones that come before. So 2.999, 2.99, and 2.9.
Now that we have our x values, we're gonna be substituting these values in this function so we can get our y values. For example, when limit of x approaches 3, we're gonna plug in like the 2.9, and for our answer we're gonna have. Now that we picked an x value and plugged it in our equation, we're gonna plug it in the calculator, and that's what we get.
We followed this procedure of plugging into the calculator with each one of our x values. Once we did that, we got all of these results. We used only 3 decimals. Once we have our results, we can see that they're both approaching a certain number here, this number and this number. So in this case, the limit as x approaches 3 would be 5.
The correct way to write this is limit of x approaching to 3 equals 5.
Okay, so the problem says solve by definition, so we have to use function of x plus h. That means we're going to add an h every time an x appears. So it will be like 3 times x plus h minus 5 times x plus h squared. Now we are going to add the limit as h tends to 0 of function prime of x, because we are doing the derivative. It's going to be 3x plus 3h, because we're multiplying this times this and this times this, minus 5, and we're going to use the binomial rule, that is a squared plus 2 times a times b plus b squared. And then we're going to subtract the original function, that is 3x minus 5x squared, and divided all of it by h. Then we're going to start solving. Limit as h tends to 0 of f prime of x would be 3x plus 3h minus 5x2 minus 10xh minus 5x squared, all divided by h. Now we're going to start canceling some terms of f prime of x. That we're going to cancel 3x with 3x and 5x2 with 5x2, so we will have 3h minus 10xh minus 5h2, all of it divided by h. And we want to eliminate as much as h as possible, so we will factor the numerator by taking out the h. So we will have 3 minus 10x minus 5h, all divided by h. and we will cancel the h, and then we will have the limit as h tends to 0 of f prime of x. And now we will start substituting that we have 3 minus 10 minus 5h. And we substitute the h with a 0, and will be 3 minus 10x minus 5 times 0, that this will cancel out because it's 0. So our final answer would be the limit as h tends to 0 of f prime of x is 3 minus 10x.
And I watch him roll away again. Yeah, I'm sitting on the dock of the bay.